All right, what do you say? We're going to start with basic figures first. All right. Today we'll talk about parallelograms and triangles. Tomorrow we'll talk about trapezoids and kites, but I'll give you all the formulas right now and tell you what each of them means. Parallelogram. I don't know if anybody remembers this one or has seen this one before. Base times height. Base times height. And if you want to draw yourself a little parallelogram off to the side there, I want to make sure you guys understand what the base and the height are. All right, the height always comes from one of the four vertices and is perpendicular to the opposite side. So that would be an example of a height. It has to be perpendicular to the other side. We had a vocabulary term for that. I just drew it. Anybody remember that from this year? Altitude. Nice job, Spence. Altitude. Altitude and height are the same thing. The base, ready? Everyone always thinks, probably from middle school, base equals bottom. The base is wherever the height is drawn to. Okay? Because I could have drawn the height. I could have drawn the height from this vertex going up. All right? The base is always wherever the height is drawn to. Okay? I don't want you guys to always just assume it's the bottom. The base is wherever the height is drawn to. All right, so there's parallelogram. Anybody know the circle one? Back in the day?
Base times height divided by 2.
Where's the base on a circle?
Oh,
That's coming up for the next one. Save that. Save that. Pi r squared.
oh, I thought we were doing triangle.
Circle.
Oh, okay.
Pi r squared. R is the radius, right? Everyone, R is the radius. All right, triangle.
Base times height divided by 2.
Yep, base times height. I do 1/2 base times height. You can do base times height divided by 2. Same thing, yep. 1/2 base times height, yep. Again, just so we're clear, height is the altitude. It's got to come from a vertex and be perpendicular to the opposite side. And then whatever the height is drawn to, that's your base. Before I move on, I do want to talk about a right triangle. Base and height of a right triangle are your two legs. All right, that's something I want you to keep in mind. When we're dealing with a right triangle, the base and the height are your two legs. All right, 1/2 base times height. Anybody know a rectangle? Rectangle? Come on. That's old school. Old school. Length times width. All right, length times width. And the two we'll focus on tomorrow, trapezoid. 1/2 the height times the two bases added together. And then again, what's the height? Comes from a vertex perpendicular to the opposite side. And the bases are the two parallel sides. I don't know if you guys remember that from our quadrilateral unit. Your bases are the two parallel sides in a trapezoid. We'll touch on that tomorrow. And then rhombus, kite, or actually, I think maybe we'll talk. I don't know if we'll talk about a kite at all. Maybe just the rhombus. Same formula though. Same formula. 1/2 d1 times d2. Anybody think they know what the letter D stands for here? We're in a rhombus or a kite. Yeah, Spence on fire today, huh? That's diagonal length. Yep. All good. before we get going on parallelograms and triangles today? Any questions? I believe, not that you need it, because you probably should already know what if you go to the back of your packet, triangle, parallelogram, and circle. All those areas are listed there in case you ever forget those real tough ones there. Okay? If they're all there for you. All right, let's just jump right into it. Find the perimeter and the area of this parallelogram. Let's start with area, because I think I know both here. Area of a parallelogram, remember the formula, base times height? Both are already there. You just got to understand what is the base and what is the height. We talk height, vertice to the opposite side, right? Vertice to the opposite side. Out of those three values, which one's the height up there? From a vertice perpendicular to the, it doesn't have to be inside either. Vertice opposite side. What's my height? Here we go. 5. What's the height here? 24. Good. So area equals height of 24. Base. The height is drawn to the base, and it's got to be an actual length on the parallelogram. You tell me, what's the base here? 4. What's the base? 23. 7 is not part of the parallelogram. You got to give me an actual side length. Good. And then we have A equals 552. Did I put perimeter too? Yeah, I didn't find the perimeter and area. Okay. Yep. So everyone's all right. And again, look, if you are going to put units, make sure, because it's area, the units are squared. But you guys know how I feel all year long. If you have units, fine. If not, that's not something I'm going to fight you with. All right, ready? Perimeter. The distance around the outside. Well, I already know one side's 23, and it's a parallelogram. Parallelogram. What's definitely another side length then? 5. I know that side's 23, and it's a parallelogram. So another side?
23.
Opposite side's congruent, right? 23. Now, what about the other two sides? They are totally blank, but we now have a method to find them. How am I going to be able to find this side right here? We got a method. Come on, this is unit 11 now. 11. 11. How can I find this length here? I got a right triangle. Pythagorean theorem. Everyone's good? 7 squared plus 24 squared equals that side, c squared, because it's the hypotenuse. We're using everything now. We're almost done with the year. Anything's fair game. Make sure you take the square root at the end. When you know that side length, let me know. Take your time. When you know that side length, let me know. 9? 25? Yep. So we got 50 and 46, 96. And again, if you're going to put units on, this perimeter would just be feet. That's it. Area is squared. Okay, we all good? It's going to get tricky. It's just not, hey, I'm going to let you guys, it's just not going to be as easy as base times height, plug it in. You're going to have to work. Maybe you do Pythag. There's something coming up that we're going to have to remember, unfortunately. Here we go. Find the area, no perimeter anymore, so just the area of each of these parallelograms. So I got base times height. One of those values you should already be able to fill in. I see my height here that's drawn perpendicular, so I don't know that value, but I see it's drawn to the base, and how long is that base going to be? Remember, it's a parallelogram, opposite sides congruent. What's the base length I'm going to use here? 2? Yeah, okay, everyone, take a look. The height is drawn to this right here, which would be my base. Opposite sides congruent. So the base is 17. You're ready for the height now. It looks like we got a review again. Everyone see the type of triangle it's in? 45, 45, 90. All right, here we go. Real quick rules again. 45, 45, 90 triangle. Our two rules. And yeah, sorry guys, hey, this is where we are at this point in the year. Legs are congruent in a 45, 45, so the two legs are congruent. And anybody want to take a stab at remembering how to find the hypotenuse of a 45, 45, 90? What do I need to do to the leg? It's a leg. Good job, Elio. Good. Times radical 2. Perfect. Great work. Leg times radical 2. 9's not my height. Actually, never mind. Never mind. Relax. I got it. I'm getting out of control. The height, is it a leg or the hypotenuse of the 45, 45, 90? Is the height the leg or the hypotenuse here? 7? Leg. And we just said the legs are congruent. Well, one of the legs was 9, so my height also has to be 9. Legs are congruent. So what do I have here? 153 square yards. Any issues yet before we go the other type of triangle that we were familiar with? All right, parallelogram, base times height. All right, I see the height drawn in. What's the base then? I can tell the base from this one. 13 base length. 32, yep. Opposite sides congruent. All right, everyone ready to find the height with me now? 30, 60, 90 rules. In a 30, 60, 90, you have a hypotenuse. You have a longer leg, which is across from the 60, right? Biggest side across from biggest angle. So the longer leg's across from 60. And you have a shorter leg, which is across from the 30. Anybody remember how to find the hypotenuse? I'll start it. Shorter leg, doing what? For the hypotenuse. Shorter leg. Even if you guess. That's coming up. You're one ahead of me. Not times radical 3, but times 2. Yep, you double it. Good. To find the hypotenuse, shorter leg times radical 2. And then, yep, we just discussed this. Longer leg is the shorter leg times radical 3. All right, so go back to the diagram. This 12, where's it across from? What angle is the 12 across from? 2. Nate, what angle is the 12 across from?
30.
That makes it the shorter leg. What's the height across from? 9. What's the height across from? Well, that's the longer leg because it's across from the 60. So I go down on my rule. How do I find the longer leg? I take the shorter leg and multiply it by radical 3. So what is my height in this diagram? What is the height here? Take your shorter leg times radical 3. 5?
12 radical 3.
12 radical 3. Good work. And what do I have? Directions. Round to the nearest tenth. Okay. So it doesn't have to be simplest radical form. $665.1, everyone. Meters squared. Again, you don't have to have the units, but whew, it's a little bit more than memorizing formulas. A little bit more. All right, any questions before we go to the triangle? All right, so you got all your rules for tonight now. It's going to be Pythag, might be 45-45 or 30-60. All right, Big Al, he's back. Makes multiple appearances in this unit. Guys can read through here. So we're looking for what's the area of triangle ACD. So let's get out the formula again. 1/2 base times height, or base times height divided by 2, whatever you remember. ACD, look at it. What type of triangle is ACD? ACD is, I'm not looking for anything fancy here, just look at the markings. ACD is what type of triangle? 9? Right triangle. And we talked at the beginning of today, when you do base and height of a right triangle, it's just the 2 legs. That's it. We're going to multiply leg times 1/2. So look, if you want to call that the height, base, there are the 2 legs. I already know 15. Right? I already know 15. How are you going to help me find this? This is 16 plus something else, right? Can you guys help me find that missing piece I can add to 16 right here? How can I find AB so I can add it to 16 and plug it in? What's going to be my method there? 12, how can I find AB there? Good talk. Where's your girl today? One job. 4, Pythag. Ooh, hopefully, whoa. Are we being careful when we do Pythag here? I'm going to ask somebody, what are you plugging in the Pythag? I want to make sure the numbers are plugged in correctly here. 5, what are you plugging in here?
15.
Yep, squared plus
B squared.
Good. I'm looking for a leg, not the hypotenuse. Equals
25 squared.
good. Woo. When you have it, let me know. What do you get for that length? 11 when you're ready? 20, yep. So that's 20. What are you going to plug into the area formula? I don't plug in 20 into the area formula. We're plugging in what here? 12? 7? 36. So we were looking at 270 square yards. So you guys starting to pick up today, hey, even though you know the formula, you're going to have to do some work probably to find one piece of it. The one piece will be given, the other one we're going to have to work for. Just like this next one. Big Al's rectangular backyard. Find the area of the garden. And the garden's a rectangle, and so is his whole backyard. If you go back, length times width, area formula. I already know one of them is 6. We're going to have to work a little bit to find the other piece now. Right? Because it's 6 times whatever that side length is. How can I get to that side length? Remember, it's a rectangular backyard as well. All right, quick question for somebody here. 7 again, Kirk, because it is a rectangle. What do you know about opposite sides of his backyard? Yep, so if that's 40, this side's got to be 40, meaning this is 25. If that's 80, opposite side's 80, so that has to be 10. And then what am I going to do to find the side of the garden? 9? Pythag. Yep. All right, what's that going to look like? 2. Nate, what's Pythag looking like here?
10 squared plus 25 squared equals c squared.
There you go. Good work. You're probably going to get a decimal here. Don't round it. We don't round until the end. You plug that full decimal into the area of a rectangle. So you guys should be taking the square root of 725, right? All right, that's a big number, but I put that into the formula. Do not round it. And then multiply it by 6. Good work here. You let me know. Round to the nearest tenth. What do you got here? 3. When you're ready, Spence.
It says it's the nearest square foot.
Sorry, nearest square foot. Thank you.
162.
Darn right. Thanks for putting me in my place. All right, we good on all these figures? Because I got one more topic to go here. We're all good? All right, so last topic, population density. I don't know, do they talk about this in science at all? Population density at all? No, okay. And I put a little definition on the top of my board up here, number of people in an area relative to its size. So let me put this as an example for you. Right now, in this room, we have a population density, all of us in this room. We go outside to the field out there, our population density got a little smaller. Okay, why? Because our area got bigger. Okay, it's the number of people in an area compared to the size of the area. All right, so because we're in a smaller space here, our population density would be higher in this classroom than out on the field out there. Okay, because they got bigger. How can you find what the population density is? I take the population and divide it by the land area. All right, so for this first example here, I went to the 5 boroughs in New York City, found their population and the area of the land of each borough. I want to know which one has the highest and which one has the lowest population density. All right, so the highest meaning most amount of people in the smallest amount of space using our formula. Okay, so easy way here. This is what I did. I just extended my chart a little bit here. So now I'm going to put population density up here. And you don't have to do it this way, but just to keep it organized. And maybe we could predict just by looking at the numbers, but I actually want to calculate each density now. All right, so go ahead, go through Brooklyn through the Bronx using our formula population over land area. Population over land area. Find the density of each of the boroughs and we'll talk. All right, highest population density ended up being Manhattan. Yeah. And I always, instead of just crunching these numbers, sometimes I like to actually show you what it would look like here visually. Here's what it looks like in Manhattan because it's per square mile. If you take a square and say one side is 1 mile by 1 mile, all right, decent sized square. In Manhattan, there's 67,000 people fitting in that square. Okay, that's what that means. Versus the lowest, which was what? Staten Island? Now remember, we had what? Manhattan with 67,000 people in this little square here versus Staten Island, about 7,600. All right, so you can start getting the idea of what population all packed into each other versus Staten Island, pretty big area, but not many people there. And before we go to the next one, and I know how much everyone loves games here, what do you think states? The state with the highest population density. So think about it. If it's got a high population density, that means it's kind of a small area, but a lot of people packed in, right? Small area with a lot of people packed in would be a high population density. What do you think? Or nominations?
Rhode Island.
You think Rhode Island?
Yeah.
Okay. Others? Anybody else?
Delaware.
Delaware? Yeah?
New Hampshire.
New Hampshire. You guys are going all northeast here, the smaller ones, huh? What about smallest?
Maryland.
Wyoming.
Texas.
Wisconsin.
Again, big area,
North
not many
Dakota.
people.
North Dakota.
North Dakota.
Or Alaska.
No,
Wisconsin.
no, Alaska.
I don't know what Tates are, but all right, let's see. Oh wait,
Oh, and
New Jersey.
Rhode Island
New Jersey.
was too.
Yeah, New Jersey. Rhode Island was up there, number 2. Yep, Massachusetts, Connecticut, so all the New England states, right? And then they're gonna go by. Yep, there we go. There it is. Alaska, Wyoming was right there too. Dakotas. So there you go. All right, highest and lowest population densities in the U.S. There you go. All right, good job. All right, one more with population density before we get out of here. Okay, I have two petri dishes. Petri dish A's got about 40,000 bacteria on it. B's got 72,000 bacteria. Which petri dish has the greater population density? Well, there's a problem here that we didn't have in the last one. The last one, we had both values and we could plug them into the formula. Remember what population density formula is? Population, which we have. That's our 40,000 and 72,000. What are we missing? The area of each petri dish, right? So that's what we need to calculate first is the area so I can do the population density. What figures on the petri dish? Circles. Go back to if you forgot it already, go back. What's the area formula of a circle? Because I need the area of each petri dish before I do the density of it. 1. And what's the formula for circle?
Pi r squared.
Pi r squared. Yep. And before we get nuts here, do I want to plug 51 in? We just finished a circle unit. Do I want to plug 51 in? No, because that's the diameter. I want to plug R, radius, so cut it in half. And I'll plug in 25.5 squared. And over here for Petri dish B, I don't want to plug in 75. I'll plug in what, 34 or 6?
37.5.
37, there we go, 37 and a half squared. And this is just giving us our area so we can get to population density. So keep that full calculator display for the area, and then I want you guys to go right to population density. So do your 40,000 over the area that's not rounded, 72,000 over your area that's not rounded, compare the two, and we'll see which one's has the greater one. Greater just doesn't always equal bigger in population density, all right? Greater does not equal bigger. Bigger size. And those should be your population densities for A and B. So easy answer now. Petri dish A has the greater one. Okay, I don't expect you to get your textbook, but at least you can flip it. Oh, hold on. Before we do that, though, please look at the bottom. When you do go to the textbook tonight, does everyone see? I didn't assign it anymore. Never mind, so it doesn't matter. We used to have a graphing problem. But that's all right. Okay, never mind. All right, but you can start at least on the density the two density problems on the back.